I will teach you limits and at infinity, horizontal asymptote. Our problem is find the horizontal and vertical asymptote of the graph or the function fx square root 2x to the second power plus 1 divided by 3x minus 5. The solution is okay. How solve this problem? How find the solution? So you divide both numerator and the denominator by the x, using the properties of the limit, we have it. Okay, we will have this limit of the square root of 2x to the second power plus 1 divided by 3x minus 5. So when x approach to infinity, okay, this will be equals to limit of the square root of 2x plus 1 again, all right, divided by and in this case divided by x, because we have divided by x both, okay, both. So we will have limit here. Let me do this way. So square root, I told you, of 2x to the second power plus 1 divided by x, here in the bottom 3x minus 5 divided by x. So when x approach to the infinity, all right, so this is equals, will be equals limit, again, limit of, we will have this case use a square root of everything here, 2x to the second power plus 1 divided by x to the second power, right? And the bottom 3x minus 5 divided by x when x approach to the infinity, right? So if you continue here, this is we equals here. I will continue here equals. We will have limit of what, of 2 on top 2 plus 1 divided by x to the second power. So it's the denominator and the bottom when x approach to the infinity, all right? Okay. This all right, and the bottom we will have limit of 3x minus 5 divided by, no, and the bottom here now is 3. As just simplify here, we will have 3 here, 3 minus 5x, right? X when x approach to the infinity, all right? This is equals, will be equals limit here. Let's let me write the sign. So on top we will have a square root of this number, limit 2, all right, when x approach to the infinity, right, plus limit of 1 divided by x to the second power when x approach to the infinity, all right. That's on the denominator. In the denominator we will have limit here 3 minus 5, okay, when x approach to the infinity. Here we will have limit 1 over x when x approach to the infinity, all right. Then almost finish it. Our conclusion here, we will have, you simplify this, it's going to be square root 2 plus 0, square root 2 plus 0, and the bottom 3 minus 5 times 0, right? How simplify this? All right, on top, of course, is square root number 2, and the bottom, we have to multiply 5 times. First, remember the rule. When you have different these problems, you have to start from left to the right and then solve first division and multiplication. In this case, we have multiplication. So multiply 5 times 0, 0. So the answer here is 3. So this is our answer in the first moment, okay? We're not finished it yet. So therefore, here, see the number. Let me write the conclusion. I will write our conclusion here. So therefore, the line, what is the line? The line is y equals, our conclusion, what was our conclusion? The square root number 2 divided by 3, okay? This is horizontal asymptote. This is horizontal asymptote, all right, of the graph, in this case, of the graph. So we are looking for the horizontal, but we have one more horizontal line. This is a positive. Let's see, in computing the limit, when you compute the limit x approach to the infinity, we must remember that for x, this is for x less than 0. All right, we have this number, square root number 2 equals x equals negative x. So when we divide the numerator by x, and the denominator by x, for x less than 0, we got it this. We got it when we divide numerator and denominator by x, okay, we got it this conclusion. So square root, look at this, 2x to the second power plus 1 divided by, when we divided x, this is equals, let me do the whole process here, 2x to the second power plus 1, the minus x, square root x to the second power, square root to the second power. This is equals a negative, everything here, 2x to the second power plus 1 divided by here x to the second power. This is equals negative square root 2 plus 1 divided by x to the second power. All right, got it? So therefore, some conclusion here. So limit here, we will write limit of 2x to the second power plus 1 divided by 3x minus 5 when x, in this case, x approach to negative infinity. So now to negative infinity, this is equals limit negative square root 2 plus 1 divided by x to the second power by 3 minus 5 minus 5 divided by x, okay, when x approach to negative infinity. All right, So this is will be equals here. Look at this, square root, negative square root of 2 plus limit of 1 divided by x to the second power. Right there, you have it. 3 minus 5. Here, limit when here when x approach to negative infinity, right? We will have our conclusion here is a square root number 2 divided by 3. All right, this is our conclusion. So therefore, look at this number, but this is negative. All right, negative, because this approach to negative infinity. So now, in the first time we got it, this number a positive. So I mean the asymptote positive. This is a negative asymptote. So at the end our class, I will make the graph. How see it? So let me erase it here and then continue with keeping in mind this, and this as a conclusion. Let me write here. That's the line y. Look at this. The line y equals to negative square root number 2 divided by 3. Yeah, remember, is also horizontal. Asymptote. Okay. So now, where is the vertical? We find it the horizontal asymptote. So now, where is the vertical? A vertical asymptote is likely to occur when the denominator, denominator 3x minus 5 is 0. Okay. When x is equals 5/3, if x is close to if x is close to 5/3 and x here and x is greater than 5/3, then the denominator is closer to 0. And 3 minus x is positive. 3 minus x is positive. Denominator, so now denominator 2x to the second power plus 1, okay, is always positive. So fx is a positive. Fx, it is positive, right? Therefore, look at as a conclusion, we are looking for the vertical line. Therefore, here, so therefore, limit. So here, limit of 2 to square root 2x to the second power plus 1 divided by 3x minus 5 when x approach to negative infinity. I mean, in this case, we are talking about this when x approach. We're talking about 5/3. Remember before 5/3. Okay, sorry, 5/3 plus. I mean to the right. Then this is equals and infinity is positive. It's positive. If x is close to 5/3, okay, but less than 5/3, then 3 minus 5 is less than 0. So here 3x minus 5 is less than 0. And so fx is large negative. So I mean, when we have here, let me write a different color, limit of, here in this case, 2x to the second power plus 1, all right, divided by 3x minus 5. But when x approach 5/3 to the left, not positive, to the left, here. So to left hands, then this is negative infinity. All right. So as a conclusion, the vertical here, we are looking for the vertical asymptote. How much is it? Is 5/3. This is the vertical asymptote. Okay. So we got it three data, 3 numbers. All right. Let's make the graph. Let me make the graph. All data that we got it from this problem. So I will to make the picture here. This is y. This is x. So one asymptote is right here. This one, remember, was a positive. It's a positive asymptote. Where is the number here? So here, this one is 5 is y equals square root 2 divided by 3. All right. So the second one, is y. We got it, another one, but negative, right? Negative. When we got the negative, is the same number, but it's negative here. Is y equals negative square root 2 divided by 3. So this is the asymptote. This is another asymptote. So the vertical asymptote is like this. So this is equals x. What is the number that we got it the last time? 5. What is the number? 5/3. X 5/3. That's the solution or our problem. But the graph, how looks the graph? The graph looks like this. Graph is like this. And then here to see the asymptote, okay? Asymptote, this is the vertical, the horizontal, and horizontal asymptote. So this belongs to this problem, okay? This is our problem. Looks like this. If you make the graph, it is like that. So find the horizontal and vertical asymptote of the graph or the function. All right. So that's it. As always, I remember you. If you discover the power of the mathematics, unleash your infinity potential.